Okay, welcome. So now I'm going to do a compound interest problem, but I'm going to show you a little bit more how I like to apply the order of operations. Now you can plug this all in a nice little handy calculator, but you don't have to as well. You can apply this either way. So I'm just going to go back again through our formula. We have A equals P times 1 plus R over T raised to the NT, where A is your final value, P is going to be your initial investment or our principal, R is your rate or your annual rate in a decimal form, N represents how many times you're going to compound per year, and T represents the number of years you're going to be compounding. So in this case, you can see that we are trying to figure out our final value. So A is going to represent, A is going to be our variable. Our initial deposit, which would be our principal, is $4,000. And that's going to be multiplied by 1 plus our rate, which is 0.0292. Notice how I wrote that in decimal form. N represents the number of times we compound. Since we're compounding this daily, there's 365 days in a year. I know we can deal with the leap year, but we'll just round to 365. And then you have 365 times 1 year. OK, so when applying this, you can plug this on your calculator, but sometimes you might make your calculator might not apply the order of operations. So I'm going to work through this by applying order of operations just to make sure you know exactly what to do. So when applying order of operations, we always want to look inside our parentheses first, right? And then we apply order of operations again, and we see we have a division problem. So I'm going to do division before I add it to 1. So I take 0.0292, divide by 365, and I get So I get 1 plus 0.0008, and then times raised to the 365. Then I can combine these. So I get A equals 4,000 times 0.12348 raised to the 365th power. Now I take 1.08 and raise it, 1.00008 and raise it to 365. All right. So 1.12348 raised to the 365th power. And that's going to give me A equals 4,000 times 1.02296. And then, so I multiply that by 4,000. And I just estimated my answer. And therefore, I will have my final value equals $4,118.52. Now, obviously, I did a little rounding of my answer here, but I just used my exact answer, and that was going to be my final value. And obviously, that is money, so we're just going to put a nice little dollar sign on that amount. So your final value after compounding a daily amount with your interest rate and an initial deposit, you will now have, after a year, by compounding daily, $4,108.52. Thanks.